Hello, everyone. I am Austin Long, and I am with Assis Paudel and Tanus Mongal. We are presenting a project we created that demonstrates the process of building machine learning modules to predict heating and cooling loads based on architectural features. This project is also known as the Energy Efficiency Predictor Project. In the next few minutes, we will show and explain the code we use for this task and how it works. To begin with, we were provided with a CSV file containing a list of numbers and information about the physical features of the model. We implemented this information and converted it into a code that predicts heating and cooling loads. We trained and tested in the model multiple times with various data sets. Though it's not perfect, this is our project and it predicts heating and cooling loads using physical features. Let's dive into it.
So we are from the going through this first coding we imported these libraries and functions upfront so that we won't need to re-import them when working on different parts of the code, making our workflow smoother and more efficient. So as we go down and we have the next one by using the remain columns. So in this code, we rename the columns of the data frame df to give a more descriptive names such as changing x1 like we have here x1, so x1 to relative compactness and y1 to heating load, from relative compactness to heating load. So this makes the data set easier to understand and work with. So the in place is equal to parameters ensure that the changes are applied directly to the original. So as we go to the next one, so we have data information and the summary here. So in this code we use df we use df.info to display a summary of the data set and including the number of non-null values, data types, and the memory uses. This provides an overview of the set's structure. Then we use df dot describe to generate statistical summaries of the numerical columns such as count, mean, and standard deviation. So this output gives us a clear understanding of the data sets, compositions, and the key statistics. So as we move into the next one, like checking the missing value by df.isNull. So on this code checks for the missing values in the each column using the df.isNull and prints the results. So it helps identify any data like quality issue to addresses before analysis. So as we go on to this code, like my friend Tanuj will be describing this one.
This code creates a heat map to visualize feature correlations with annotations and a cool warm color scheme and adds a title correlation matrix. This code creates scatter plots for each feature against heating load. It loops through the specified features, arranging the plots in a 4-2 grid. Each plot shows the relationship between heating load and one feature with labels and titles for clarity. This code defines the features and target variables. The features include columns related to building attributes, while heating and cooling represent the target variables for heating load and cooling load, respectively. This code splits the data into training and testing sets for both heating and cooling load. 80% of the data is used for training and 20% is used for testing, ensuring a random but consistent split with random state 42.
We use linear regression and random forest regressor to build models for predicting heating load and cooling load. The models are evaluated using the following performance metrics: mean absolute error, root mean squared error, and R squared. The predict HVAC load function predicts heating load and cooling load based on user-provided features values. It uses the trained heating and cooling models to make predictions after creating a data frame from the input features. The function returns the predicted values for both loads as a tuple. This code loops through a list of example feature sets and uses the predict HVAC load function to predict heating load and cooling load for each set. For each set, it prints the predicted values, and if an error occurs during prediction, it catches the exception and displays an error message for that particular example.
After doing this project energy efficiency, so we did some encounters a few issues during the completion of this project, including but not limited by the following things. First, First, we had doubts about the training data being sufficient on it or not, with limited experience in training and testing sets. So we had to do more research than expected. However, I believe we managed fairly well. Secondly, we faced difficulties with our final output, which we have not perfected yet. While we could not get our code, to generate the exact output we wanted. We did we did get very close. This portion of the project still needs some work. So lastly, we struggle with understanding and interpreting the heat map, and the scatter plots. We had to do additional research on these, but overall we gained a solid understanding and successful completed all the tasks. So as we done with the encounters of few issue on this project, my friend Thanos will be go for the evaluation of this project. Thanos.
This report evaluates the participation and contributions of each group member for our energy efficiency predictor project. Throughout the course of this project, I believe all of us demonstrated strong dedication and collaboration, playing vital roles in achieving our goals. In this report, we'll evaluate each other based on our contributions and teamwork over the past few weeks. Ashish was a big help on the energy efficiency predictor project. He understood what we were aiming for and played a key role in building the model. He handled data pre-processing, feature selection, and put together important parts of the system. Ashish was active in team talks, throwing out solid ideas to improve accuracy. His teamwork and clear communication made sure we got things done on time. There's always room to grow, but his work was definitely crucial for the project's success.
Anus made significant contributions to the energy efficiency predictor project. He demonstrated strong analytical skills and a deep understanding of the project requirements. Asness effectively implemented features contributing to model development and helped in data pre-processing. He actively participated in discussions, offering valuable insights on improving the accuracy of predictions. His teamwork and communication were excellent, ensuring smooth collaboration. While there's always room for further refinement, his contributions played a vital role in the project's success. It was great working with them. Thank you.
Thank you.